get them
All right.
online.
So we're going to look at partial fraction decomposition. So if you look at the problems that we're working with, when you were in Algebra 1-2, you were given 2 or 3 fractions that had different denominators that you had to make into the same denominator. And then you had to combine them into Jagger. That's 1. You had to combine them into one fraction. So now I'm giving you the one fraction, and you have to tear them back apart into their separate fractions. So each denominator of these fractions will be different. So let's look at example 3. You've got a list of steps. This is your process that you're going to follow. So you're going to see me going 1, 2, 3, 4, 5 in the order of those steps. So write small because there's a lot of work that's associated with this. So the first step says to factor your denominator. Each factor is one of the new denominators. So that's kind of what I already alluded to. So if I factor x squared minus 3x, let's try to get that non-fuzzy. Oh yeah, that's better. Okay, there we go. So factor that. What do you get?
X times x minus 3.
That was wonderful. So that means that one denominator is going to be x and one denominator is going to be x minus 3. So then step 2 says place a, b, c, etc., however many I need, over each new fraction. So for step 2, I'm going to take my original, which was 3, over x squared minus 3x, and set that equal to. I'm going to begin to pull apart the fractions. So my first factor is x. So I'm going to put a over the x. I'm going to add to that b over the other factor, x minus 3. So then step 3 says find your basic equation by multiplying the original fraction and the new fractions by the common denominator. Isn't that your least common denominator? So you might want to add here your LCD. Whatever you factor your original denominator into, this is the LCD. So we're going to take step 1 and multiply it to every single term in step 2. So this is where it takes a little bit of room. So write small. So step 3, I'm going to take x times x minus 3 over 1, and I will multiply that to the 3 over x squared minus 3x equals. And then do it again. X times x minus 3 over 1 times a over x plus, and then one last time, x times x minus 3 over 1 times b over x minus 3. And the whole point of multiplying by the LCD is to get rid of all of your fractions. Your basic equation should not have any fractions in it. Wouldn't you agree that this entire denominator here cancels with both of those factors since we factored this and got that? So all of those factor that entire denominator, and you are left on the left side of the equal sign with just a 3. And then this x cancels with that x, and you're left with an x minus 3 and an a. I prefer to put the a in front. Then this x minus 3 cancels with that x minus 3, and I'm left with an x and a b. So again, I prefer to put the b in front. So this is our result, and this is our basic equation. That's what we've been looking for. So now our job is to find out what a and b are. Once we know what a and b are, we can plug them back into the a and b here, and then we'll have our 2 separate fractions. So step 4 says put in different values for x that generate zeros, and other letters will fall out. So I'm looking for zeros. In Algebra 1-2, when you learned to factor your denominator, didn't we look for restricted values? What value is going to make x 0? 0. What value is going to make this 0? 3. So those are the values that step 4 is looking for. You're looking for things that make the factors in your denominator 0. Because I want to be able to zero out one of these two to find the other one. So step 4. I am going to let x equal, we'll start with a 0. So I'm going to take that basic equation, everywhere I see an x, I'm going to put in a 0. So I have 3 equals, I don't know a, but instead of x, I'm putting in a 0, minus 3, plus b, and instead of x, put in a 0. Doesn't this 0 out? And then 0 minus 3 is negative 3 times a. So I have 3 equals negative 3a. I don't have to write this because it's 0. So what's the value of a? Negative 1. So there's 1. Then we're going to do it again, but this time we're going to let x equal 3, our other 0. Try not to lose my basic equation. So 3 equals a times, instead of x, I'm putting in a 3, minus 3, plus b, and instead of x, we're putting in a 3. Three minus 3 is 0, times a is 0. This time the a term zeroes out. So I end up with 3 equals 3 times b, which is 3b. So what does b equal? Positive 1. So now we have our a, we have our b, and we can write our fractions. So the final step, step 5, write your partial fraction. So here's your final answer, bless you. You want to write the original fraction first, so you've got 3 over x squared, here's easy, equals, and then we now know what a is, and so if I go all the way up here, my a, we found out, was negative 1. Thank you. Sarah? It certainly doesn't look like it. You could just go and quickly come back. All right, so my a was negative 1, so I'm going to replace this a here with negative 1, so it'll be negative 1 over x. And then my b was 1, so I'm going to zoom back out. My b was 1. So whatever the sign is of the following terms after the first term is, whatever that sign is has to go here. So if b happened to have been negative, we would not have written plus and negative up here, because we don't want double signs. So fortunately for us, b was positive, but if b had been negative, we would have put a minus for the sign here and then put your b over, whatever the x minus 3. So our b is 1, so we put a plus 1 over the x minus 3, and we're done. So that's your answer that we're looking for. If you were to remultiply these, find their LCD, make them the same denominator, multiply them, you should end up with this original fraction again. All right, so the second example was chosen on purpose because it has a different situation than example 3. We're going to go ahead and follow the same steps. Factor that denominator, what do you get? What do you get? Yeah, the GCF is x squared, so you get x squared times x plus 1. So here's the problem. You cannot put a over x squared and b over x plus 1. Anytime one of your fractions has a power other than 1, you have to go in successive order of that power. In other words, because this is x squared, I really have a factor that's x and a factor that's x. So in order to make our fractions work out, in other words, if I decompress my fractions and break them apart, in order to get the LCD again, get the same like denominators and add them back together again to get the original fraction, we have to not only do a over x squared, we also have to have something over x. So we have to go backwards. We have to go x to x squared. If this were x cubed, we have to have an x squared, and x cubed. So I have to have two fractions to deal with this x squared. If it's a cube, I have to have three fractions to deal with the cube. If it's to the fourth, I have to have four fractions to deal with it. If this were raised to the third power, I'd have an a over the x plus 1. I'd have a b over x plus 1 squared. I'd have a c over x plus 1 cubed. Now that looks like Andy. And Andy, I'm going to write you a pass. I would say you lump it together. Might not be on until an hour or two after school. We should ask you why you didn't come out to school, just so you know. I told you must have school going on. Okay, so my point here is the difference between these two is these factors were raised to the first power. We didn't have to do that. If you have a factor raised to any power other than 1, you have to go in successive order of that. So, for step 2, before we start our general or our basic equation, our original fraction is x minus 1 over x cubed plus x squared equals. To deal with the x squared, we're going to have an a over a single x plus a b over an x squared. So I had to go in successive order. So as I said, if this had been an x cubed, this would all be the same. I'd have plus c over x cubed. If you don't, it's not going to work out correctly. So then here, I have just something to the first power, so then I can just put c over x plus 1. And the other thing that I want to point out, before we can ever do fractional decomposition, your numerator needs to be 1 degree smaller than your denominator. If the degrees are equal, you have to do long division. I should not have given you any problems where they're equal. And if they're greater than, that's another issue altogether. But you should always have, and this one, same thing, what's the degree of the numerator here? A constant, what's the degree of a constant? You don't see a variable, so it would be x to the 0, right? So this has a degree of 0, all constants do. What's this degree? We should go all the way back to algebra 1, 2. We've talked about this in this class before. The degree of this one is 1. The degree of this is 2. The polynomial carries the degree of the highest term. So the polynomial has a degree of 2. What's the degree of this one? 1. What's the degree of this one? Not 2. That one carries the degree of the highest term. So this one, I misspoke. This one is a smaller degree than this one. That's all we care about. It doesn't have to be 1 degree smaller. It just can't be bigger or equal to. Then we have another step. So my point is I should not have given that to you. All right, so here's what we're going to start with. How do we get rid of those fractions? What do we do? Multiply them all by the LCD, and this is our LCD right here. So write small, because we've got 4 fractions. So we've got x squared times x plus 1 all over 1 times x minus 1 over x cubed plus x squared equals x squared times x plus 1 over 1 times a over x plus x squared times x plus 1 over 1 times b over x squared plus squared times x plus 1 over 1 times c over x plus 1. Then we start canceling, and the denominators had better all cancel out. So this entire denominator cancels with both of those factors, and we are left with an x minus 1 on the left. And then this x cancels with just one of those x's up there. So I have an x plus 1, and an a. I choose to put the a first, then the x plus 1. Then in the second fraction, both x's cancel. This is like Grand Central Station today. So then I have a b. Oh, it's kind of be that. I have a b times x plus 1. And then the x plus 1 cancels with the x plus 1, and we end up with plus cx squared. So this entire thing is our basic equation. So it's a bit more complicated than the last one. Are we okay with that so far? Other than accepting the fact that I can't just have an x squared, I have to have an x along with it. All right, so next, what do I do? So 0 will make that 0, and what else? -1. So that's going to give us 2 of our answers, but we're going to be shy in answers. So we'll have to talk about how to get that last one. So we're going to let x equals 0, so we'll start there. So wherever you have 0 in for x, or put 0 in for x, so I'm going to start off with 0 minus 1 equals, I don't know a, put in 0 for x, 0 plus 1, I don't know b, 0 plus 1, and then plus I don't know c, but we're going to square the 0. So the nice thing is that I end up with 0 plus 1 here, which is 1, times 0 is 0, times a is 0. So the whole a term will cancel out, become nothing but 0. Won't the c term cancel out also and become nothing but 0? All we're going to have left on the right is the b term. On the left, 0 minus 1 is -1 equals. Then 0 plus 1 is 1, times b is b. Didn't that just solve for b quite easily? Because this whole term, from here to here, that the whole term is the a term. So it doesn't matter that 0 plus 1 is 1. When I multiply for that 0, I get 0. And then times a is my 0. Right? Are you good with that? All right, so then we're going to let x equal -1, because that's our other 0. So do it again. We've got -1 minus 1 equals, I still don't know a, times -1, and then -1 plus 1, plus, I do know b, but it won't matter in this case. You can put in the b if you want to, since you found it. But as you can see, it's still going to 0 out because x is -1 plus 1, and then plus, I don't know c, but x is -1. So be really careful. What's -1 and -1? It's -2, right? It's not 0, it's -2. -2 equals -1 plus 1 is 0, times -1 is 0, times a is 0. So the whole a term zeroes out. The b term also zeroes out because you've got -1 plus 1 is 0 times b, so that zeroes out. So we're left with the c term. What's -1 squared? 1 times c. So again, doesn't this solve for c without much work? So we now know b, we know c, but we don't know a. We're out of zeros. So when that happens, you need to select anything you want to for x. I would select something easy and something that's not a 0 that you've already used, because why use something that we've already used? So we're going to choose any value you want to for x. What would you like to choose? I'd be choosing 1, right? If it's not one of my zeros, I'm going to choose it. And I certainly would not choose a negative. You could, but bad things can happen with your negatives. So I'm going to choose 1 plus, we are going to have to plug in the value for b and the value for c, because 1 is not going to zero anything out. So we are going to let x equal 1. And you might want to write in here, choose any value other than, and that's only in this case, 0 and -1 for x in order to find a. Because you're going to go, how did you decide to choose 1? And you'll forget. All right, so let's plug it in. So I've got 1 minus 1 equals, I don't know a, that's what we're finding. My x is 1 times 1 again, plus 1. My b is negative, so I'm still going to put plus, but I'm going to put parentheses for my b. That's a -1. And then times, my x is 1, plus 1, plus I do know my c. My c is -2 times, we're letting x be 1 squared. So make sure you follow your order of operations. On the left, 1 minus 1 is indeed 0. Follow your order of operations here. 1 plus 1 is 2. 2 times 1 is 1 times a, so we get 2a. Order of operations start here. 1 plus 1 is 2. 2 times -1 is -2. And then square the 1 first. 1 squared is 1 times -2 is another -2. -2 is -4. So if I add 4 to both sides, won't I get 4 equals 2a? So what does a equal? 2. So now I have everything needed to write my final fraction. So I'm actually going to write them up here because I ran out of room. So step 5. The original fraction, I'm just going to go ahead and write it right here. Here's my original fraction. X minus 1 over x cubed plus x squared equals, and then here I've got a, well we just found a to be 2. So 2 over x plus my b is -1. Oh, so instead of a plus, what should I put? A minus, right? Because I don't want plus and negative. This is a minus. My b was 1, so 1 over x squared. And then my c is also negative, so minus 2 over x plus 1. So here's my final answer. Now let me caution you on something. Is it possible that I could have put a over x plus 1 and c over x squared? Is it possible? Yes. So it's possible to put your denominators in a different order. That's okay. That means that your a, b, and c are going to be different than my a, b, and c, but overall, shouldn't we still have the same fractions? We should. So that really doesn't matter. But how you factor your denominator matters, and how you write those factors as denominators does matter. So this one is slightly different than this example here. Questions on that before we do the last one? Very excited, I can tell. All right. The last problem, we are going to find an equation given points. We're going to fit a curve to these points. there's an easier way to do this and a harder way. We'll have a easier way later. This particular one isn't all that difficult. But all I have are 3 xy values. So this is an x, and that's a y. This is an x, and that's a y. And this is an x, and that's a y. So I'm going to color code them. We have to find a quadratic. So obviously this is a problem in the form of ax squared plus bx plus c. We've got to find a, b, and c. Find out what those values are. So we're going to use previous knowledge. So when x is equal to -1 and y is equal to 3, that's our first point, we're going to plug in the x value for the x's here in the general quadratic equation and the y value for the y here. I like my y value on the right because it's going to be a constant. I want this to look like a normal system of equations. So I'm going to choose to do a, and then the x is squared. So I'm going to take my x here, which is -1, put it in there, plus b, instead of x, we're putting in our -1, plus c equals, and instead of y, we're putting in a 3 here. So that's going to create one equation. We do the same thing with the second point. When x is equal to 1 and y is equal to 1. I'm going to run it through the same original general formula. A, my x is 1 this time squared, plus b, x is still 1, plus c equals, and this time my y is 1. So that creates our second equation. Note I have 3 unknowns. How many equations do I need? 3. That's why you have 3 points. So when x is equal to 2, y is equal to 6. A times, instead of x, we're putting in a 2, plus b times, instead of x, we're putting in the 2 again, plus c equals our y is 6. So this produces the following system. So we're going to go ahead and square those values and multiply them to the a, the b, and of course the c is going to stay alone. And yes? Oh, it's a, this? It's an asterisk. That was a really good one, wasn't it? All right, so let's find our equation. So this first one, -1 squared, is just 1 times a is a. -1 times b gives us a negative b. C stays plus c equals, the 3 doesn't change. So there's one equation. Our second equation, 1 squared is 1, times a is a. 1 times b is b, so plus b, plus the c equals 1. Then the last equation, 2 squared is 4, times a is 4a. 2 times b is 2b, or not 2b. Yeah, that was funny. Equals 6, or not. So there's my system. Don't you know how to solve a system with 3 equations and 3 unknowns? Here we go. Now, you could choose to put it in row echelon form. That's fine. Or, oftentimes what I'll do is I'll try to get 2 equations that have the same 2 variables in them. So, like for instance, if I added those 2 equations, won't the b's drop out? So I'd end up with an equation that has a's and c's in it. So then I would want to get another equation that has just a's and c's in it, so that I can put those 2 equations together and solve for either a or c, right? Once I have a or c, I can plug it back into one of the equations that has just 2 variables and find the other one. So I'll give me 2 variables, and then when I have 2 of them, I can plug it into one of these to find the third, right? What would you like to do first? And you can write as many notes to yourself as you need to help you remember why we did what we did. So what shall we do first? No, you tell me. You already know how to solve a system. I gave you a helpful hint. What would be easiest to start with first? Well, we could, but this actually isn't going to give us quite exactly row echelon form. But if I add these two together, I'll drop out my b's. I don't have to do anything, we just have to add them together, right? So step one, let's take those two equations, a minus b plus c equals 3. I'm going to add to it the second equation, a plus b plus c equals 1. When I add those together and do nothing to them, the b's do drop out. I get 2a's plus 2c's equals 4. Now we could simplify this equation because every term has a GCF of 2. You could go and divide it out if you wanted to. Let's wait and see what the other equation is that we have. So step 2. What other two equations could I put together to get rid of the b's? I can't do the first two again. I could do the first and the last, right? What would I have to do to get rid of the b's? And I like doing the first and the last because the b's have opposite signs, right? So let's go with that. So we're going to take a minus b plus c equals 3, and then the 4a plus the 2b plus the c equals 6. We're going to have to multiply that first equation by just a 2. No need for a negative. And we get 2a minus 2b plus 2c. And don't forget to multiply to the 3 to get 6. Bring down the second equation that we didn't touch. And now add. So my b's do indeed drop out. I get 6a plus 3c equals 12. So now we have two equations with just a's and c's. There's really no need to divide out the 2 here. If you look at the two equations together, I've got 2a plus 2c equals 4, 6a plus 3c equals 12. You have to choose, do you want to get rid of a's or c's? Which would be easier? If you get rid of the a's, you just have to multiply the top by negative 3. If you get rid of the c's, you have to multiply both equations, one of them by negative, right? So it would indeed be less work to multiply the top by negative 3. So we get negative 6a minus 6c equals negative 12. The second equation remains untouched. And an interesting thing occurs. Our a's do drop out. We get a negative 3c equals 0. So the 12's drop out. So what must be the value of c? 0. Do you remember what c is in the quadratic equation? It's the constant, and it's also the y-intercept. So that tells me that our parabola must cross somewhere at the origin. Either the vertex is at the origin, or one of the arms of the parabola is crossing through there, right? We're going to check it on our calculator later. Okay, so we have c. What do we do now? Yeah, plug it into one of these two. Find a. This one has smaller numbers, so I choose to plug it into the top one. So we have 2a plus 2 times, instead of c, we're putting in 0, equals 4. Well, this obviously is 0. So I have 2a equals 4. What does a equal? 2. So there's our second. So now I have a, I have c. How do we find b? We have 2 of them. Can I go back to my original system? Plug in for 2 and find 1. Which one seems best to plug into? It's the second one, definitely. So we're going to take a plus b plus c equals 1. And we're going to replace what we know. We know that a is 2. I don't know b. But I do know that c is 0 equals 1. you want to just subtract 2 from both sides? Won't b equal negative 1? So now I can write my equation for the quadratic, and we're going to check it on the calculator to see if we're right. So my general formula is y equals ax squared plus bx plus c. So we're going to replace y equals, we're going to replace a with 2 x squared. Our b is negative, so we don't want to write plus negative. We're just going to write minus, and the coefficient's 1. We're just going to write minus x. And then our c plus 0. Would that be my answer? Would it be? Nope, because we don't want the 0 in there, right? So our final answer is y equals 2x squared minus x. So take your handy dandy calculator. Go to your y equals, and you're going to put in 2x squared minus x. And hopefully it looks like a parabola. And looky there, it does go through the origin. What's the easiest way to check? We've got a picture of the graph. How do we know that those points that we started with are on the graph? We can sub them in. Go through my calculator, where do I look for that? Yep, so go to your table, right? So plug in those values. There's negative 1, right? So here's my negative 1 for the first point. And lo and behold, the y does indeed equal 3. And then I put in 1 for the second point, and my y does equal 1. And I put in 2 for the third point, and y equals 6. Yippee, skippy, yippee, chippy. Yay, we're done, right? So it does work. Questions? Yes. Hiking, what are you doing? Going on a date to a movie? All right.